Welcome to BCIS 1305. This is Dr. Schuessler again, and today we're going to be talking about Chapter 7, Input and Output. So let's go ahead and dive on in and see what the objectives are for this chapter. We're going to start out, we're going to talk about keyboards, and we'll talk about some of the basics of keyboards initially, and then we'll talk about some of the different specialized types of keyboards that are out there. We're going to talk about some of the characteristics of different pointing devices. We'll talk about various uses of touch screens and some of the different ways we can interact with those touch screens, whether we use our fingers to be able to do it, we use styluses, etc. We're going to talk about some of the different types of motion input, voice input, and video input. We'll differentiate among various scanners and reading devices. We'll talk about some of the characteristics of various displays, some of the different types of printers. We'll talk about the purpose and features of speakers and headphones and all those types of things. And then the chapter finishes up talking about assistive technology used for input and output. Okay, so what is input? We've talked about this earlier in the semester, but it's a way of getting information or getting data into the computer. So we need to be able to, if you'll recall from earlier lectures, the IPO model, input, process, and output. In order to be able to process something, we need to be able to have data that's input into the system to be able to be processed. So some of the different common ways of inputting that type of data into the system is through the mouse, through a keyboard, through touch screens, etc. So there's a lot of different ways of getting data into the computer system, and that's really what about the first half of this chapter talks about. So what are some of those common input methods? Well, keyboards, pointing devices, touch screens, pen input, motion input, voice input, video input, and scanners and reading and other reading devices. Keyboards are pretty much what everybody thinks about. The traditional full keyboard is what's referred to as a QWERTY keyboard. If you look at the typing area on your keyboard across the top row, you'll see the word spelled out QWERTY, Q-W-E-R-T-Y. And this really comes to us kind of a holdover from the days of typing, typewriters, in which we had to separate the commonly used keys out so that the mechanical device didn't jam as we were typing up a document. And that has kind of stuck with us into the modern use of computer keyboards. There are other types of keyboards that are out there. For example, there are Dvorak keyboards that exist, which has a different layout of the keys. There are more efficient layouts of keys. This is simply, QWERTY keyboards are simply something that we've used out of convention, again, because of the days of the typewriter. In addition to the typing area, we've got other keys on the keyboard. Some of them are referred to as function keys. Those are those F keys along the top. Those aren't typically used nearly as often as they once were in the days when we had command line interfaces and we had programs that required function keys. A lot of times you had a template that sat across the top of your keyboard, and those function keys would do different things depending on the toggle key. You'd have a toggle key that would allow a key to perform more than one function. An easy example of this is the shift key, for example. When you click the shift key, it allows you to have a capital letter or a lowercase letter. And so it's shifting the function of that key. We have our arrow keys that allow us to move the cursor around in different directions. Some keyboards have media control buttons that allow you to pause music, start your media player, etc. And then in some keyboards will have internet control features, internet control buttons as well, that allow you to launch your default browser, allow you to launch your default email client, things like that. Other types of keyboards, those that are built into your laptop. Some tablets have clip-on keyboards, or some that connect via Bluetooth. And then you've got on-screen keyboards built into a lot of tablets and smartphones and things like that. In some cases, there's a need for what's referred to as an ergonomic keyboard. And these are keyboards that are specifically designed for those who might suffer from arthritis and people that are concerned with carpal tunnel syndrome and things like that. And allows you to work more comfortably and hopefully to prevent some of those types of injuries or reduce any aggravation that might be created from the traditional use of or the use of a traditional keyboard. Shifting over to a mouse, this is a mouse is one type of pointing device. A pointer is a small symbol on the screen whose location and shape changes as the user moves the pointing device. So when we want to be able to select something, we move the pointer to wherever it is that we want to select, and we use the pointing device to be able to select that particular option. The dominant device in this area obviously is the mouse. And when we talk about a mouse, we've got several different options. We've got optical mouses, we've got laser mouses, we've got touch mouses. Very early on, we had what was referred to as a ball mouse, and literally on the bottom side there was a ball that would spin around as we manipulated the mouse. And there were a couple of sensors that were built into the bottom of the mouse that would read the position as that ball moved to tell the cursor where to move on the screen. An optical mouse, instead of having that ball, it uses light to be able to sense the motion, to be able to detect that motion, that movement of the mouse. And this works quite a bit better than the ball mouse. The ball mouse would tend to pick up dust and dirt and things like that, and over time it would start to affect the performance or affect the movement of the pointer on the screen. So a move to optical mouses or mice has really helped us out quite a bit. A laser mouse is a specific example of a type of optical mouse. Again, the type of light that's used in that case is a laser. And so those are the traditional mice that we're familiar with. They have various keys or various buttons on them, 2, 3 buttons in most cases. Some of them will have a wheel button as well. And they allow us to scroll quickly and easily and things like that. There's also another category or class of mice that's referred to as a touch mouse. And this extends the functionality. It's able to actually read different types of input on the top of the mouse, in addition to reading the movement around like a traditional mouse and being able to click in certain areas. It also allows you to do things like swipe and pinch and things like that, so it can read other gestures as well. Other types of pointing devices, we've got touchpads, which are commonly seen on laptops. We've got pointing sticks, which are also commonly seen on laptops, though they're not quite as much as touchpads anymore. And then we've got trackballs, which in the early days of laptops were on some laptops. Today you don't see a lot of trackballs, but they do have some very specific applications, especially in environments where you have very limited space, and moving a mouse is sometimes a bit of a challenge due to limited space. A trackball can be a nice feature. Essentially, it's taking that ball mouse that we were talking about a moment ago and flipping it over on the other side, and you can manipulate the ball directly. So rather than moving the entire mouse, you simply move the ball. A trackball is designed for that purpose. We can also manipulate the pointer through a touch screen. The touch screen is going to be able to sense our actually touching the screen. In some cases, that's simply using our finger to be able to manipulate it. In other cases, it requires some sort of a pen input, in which we'll use a stylus to be able to manipulate the pointer, sign documents, things like that. Another use of pen input is with the use of a graphics tablet. It's used a lot by graphics artists to be able to create drawings and manipulate drawings with different types of color and lines, things like that. Very interesting field. It's interesting to watch a graphics artist work because essentially they're working from a blank tablet and they spend all their time watching what's going on the screen. So this is really pretty good, even though it looks like this person on the screen here is drawing or working with a CAD environment. Graphics artists a lot of times will have a drawing up there of a picture, and they'll be able to manipulate the colors and the shading and all that kind of stuff with a blank graphics tablet, and you're simply watching everything that's going on the monitor. So it's a really pretty interesting process to watch. Another type of input is motion input, and this is something that's going to measure how you move. And you see this a lot in video games, for example. The example they're showing here is golf, but you see it a lot of times in baseball, bowling, those types of of games as well. There are actually motion input mice as well, wireless mice that you can hold in your hand rather than having to have a surface to move the mouse around on. It simply measures the movement in your hand and how it's balanced and things like that to be able to manipulate the pointer on the screen. So there's a variety of different ways to manipulate that type of input. We've also got voice input. This is something that up until just a few years ago was really very much so a novelty. Voice input has come a long way. It's much better than it was just a few years ago. It's still not perfect. It's still not. It still doesn't work really well. But it has really come a long way. Siri certainly has kind of pushed that envelope quite a bit. Now you see offerings from Google and Microsoft that try to do the same thing, allow you to use voice recognition to enter searches, for example, in Google, to ask for directions, call certain people, things like that. So certainly things like the amount of memory that our devices have, the processing speed, the number of cores that our processors have, are really what's driving this and facilitating the ability to process voice input. Related to voice input, we've also got audio input. So in addition to just speech, we may also want to input things like music or sound effects. And this is what's going to allow us to manipulate a song and to be able to process that song into some other different form of output. So we may want to add sound effects. We may want to clip the end of the song or merge a song with another song or have a song fade out. So being able to input that audio into the system to be able to process it is what allows us to do that. Much like audio input is related to speech input, video input is related to audio input. Usually when we input video, we want the sound to go along with it. And so video input usually is going to get into our system via some sort of a digital video camera. A lot of cameras and camcorders, phones have the ability to capture video, and that's one form of inputting that information into our computer so that we can process it. Webcams are another popular way. In addition to a traditional video camera, we can use a webcam to do a variety of things, and these are built into our laptops. We can buy them third-party for our desktops. It usually allows us to capture images, still images. We can broadcast live images over the internet. YouTube has this functionality built into it. We can conduct video conferences. We can make video calls with Skype or Google Hangouts and things like that. So webcams really allow us to do an awful lot. It's what allows me to do this video right here. So here's an example of a video conference call that's going on. It allows basically different parties to get together and interact, be able to see each other and see expressions and hear the tone on people's voices. It allows organizations to save a lot of money. They don't have to spend so much money on airfare and things like that. At the same time, it allows families to stay closer, to be able to talk to each other and see each other when they're apart. So video conferencing is a nice way to be able to do things. Another type of input is scanners and reading devices. The scanner is some sort of a light sensing input device that's going to allow us to capture something on a page, whether it's an image, it's printed text. It allows us to capture that and turn it into a digital form. So it's going to operate basically like it illustrates here, but it really operates a lot like a copy machine does. The only difference is rather than taking that image and sending it directly to another sheet of paper, that copied paper, it sends it to that digitized form, a file that we can save on our computer. And then we can print that out if we want, we can email it, we can share it with other people, things like that. An optical reader is a device that uses a light source to read characters, marks, and codes, and then converts them into digital data that a computer can process. So the idea behind an optical reader, is that it does more than just capture that image. It actually processes it and turns it into information. So let's say, for example, we scan a Word document that has a bunch of text on it. If we simply scan it as an image, we can't do a lot with that. We can read it, but we can't edit that text. Well, with something like optical character recognition, now we can go back in and actually edit that text because it understands what those words are. It understands what those letters are. So that actually allows us to manipulate the text that's on there. It sees it more than just as an image. This is related to optical mark recognition. You see this in things like scantrons, for example, that reads where bubbles are, for example, the answers that students have bubbled in on an exam. It allows you to run a class, for example, and create totals based on their marks. Related to this are things like barcode scanners and QR code scanners and things like that that allow you to read some of these codes. This is kind of related to the next one. I want to point this out before we move on to the next one. When we look at a barcode here, for example, basically what we have here with a barcode is a representation of these numbers right here. The spacing between the different lines represent different numbers. So the spacing between all these lines represents this number right here. That's why when you're at a grocery store, for example, and it won't scan if the barcode is damaged, you can manually type in this number and it knows which product you're talking about. QR code's essentially the same thing. It's just a 3D or not a 3D, a two-dimensional representation of a barcode. The idea behind both of these is it shows you a class of something. So the very first barcode was, I believe, was on a stick of Wrigley's gum, or a pack of Wrigley's gum, I should say. And it would represent, a barcode would represent that kind of Wrigley's gum. It couldn't tell you about a specific pack of Wrigley's gum, but any of that kind of Wrigley's gum, that barcode would tell you that that's what it is, this is how much it's going to cost, etc. It's a little bit different when we start to talk about RFID. RFID gives you the ability to identify a very specific pack of gum. So take, for example, the example I used in class was talking about pharmaceuticals. That if a pharmaceutical company has a bad batch of drugs, they need to know which specific batch of drugs that it is in order to be able to recall that batch of drugs. If they don't, they have to recall all their drugs that they produce that might be suspect, because they can't narrow it down to a specific batch. They simply know it's a type of drug if they're using barcodes. But with RFID, they can track each individual package of drugs. And so it gives you a lot more granularity with respect to control. Something else, another distinction with barcode scanners and QR code scanners, you have to physically be able to see the barcode. You have to physically be able to see the QR code in order to be able to scan that code. With RFID, it gives you the ability to read that code via radio waves. As a result, you don't have to see the tag directly. It uses those radio waves that can travel through things in order to be able to read the RFID tag. And so that gives you a lot more flexibility in terms of how you package things and how you stack things. And you see RFID used quite a bit in managing inventory. Libraries use them to keep track of books and things like that. Other types of scanners include mag strip readers. These are readers that read that magnetic code that's on the back of your credit card, the back of your ID and things like that, and it just reads the information that's encoded into that magnetic strip. Another type of scanner is MICR, or magnetic ink character recognition scanners. These are scanners that are designed for use in the banking industry to be able to read and process checks. They read the information across the bottom of those checks so that they can properly route the information to look at things like the account numbers, the routing numbers, etc. So it allows them to process a high volume of checks very quickly and efficiently that otherwise might take quite a bit more effort to be able to do. And the last part of this section talks about portable scanners. And these are scanners that allow you to collect this information on the fly or on the run. And essentially, they're going to operate in two different categories. They're going to operate in two different classes or categories, if you will, that allow you to collect information, and all that information is housed and stored in that portable device. And then that portable device gets taken back to, say, some sort of a base station or a desktop computer or a laptop computer and plugged up. And that information then gets transferred and updated into the system. Others connect wirelessly so that you have up to the date, up to the second information as that portable device scans in whatever it's scanning in. So whereas the first half of the chapter talked about the input side of the equation, once we've processed it, we want to be able to do something with that information. We want to be able to print it out so that we can hand it to somebody. We want to be able to email it to somebody. We want to be able to save it to our hard drive or removable drive so that we can process it later, things like that. So that's what the second half of the chapter talks about. Whereas on the input side of things, the two dominant types of input were the keyboard and the mouse, on the output side of things, the two dominant types of output usually are going to include some sort of a display and a printer. Those are the two dominant ones, but there's lots of other ones as well, and we'll talk about those in the next several slides. But we're going to start out with displays. Display visually conveys text, graphics, and video information. It's usually going to be, at least on a desktop computer, a monitor. It's a display that's packaged as a separate peripheral device. The standard display monitor used to be a CRT-based monitor. Today, it's pretty much always going to be an LCD monitor. And it's just a special kind that tends to use less power. They're thin. They give us that thin, lightweight. They give us the ability to save some desktop space in our offices and consume less power than those CRT-based monitors. So you see several examples in the image down there of different types of displays. Our our LCD monitor displays that are built into laptops, they're built into cameras, smartphones, and tablets. They're just everywhere. We see them all over the place. And you see them at the grocery stores, you see them at retail outlets, you see them at the mall. So they're just everywhere. When you're in the market for a display, you've got several things that you need to take into account. You need to obviously take into account your budget. The bigger your budget, the more you can afford. So more becomes what represents more when we talk about a display. Well, the size is one measure of more that they don't really talk about here. But there's also resolution. In other words, how much detail can you show on the screen? The higher the resolution, the more detail you're going to be able to have. So if a lot of detail is very important to you, you're going to want a high resolution monitor. Response time. If you're a gamer, if you like things where there's a lot of images that change scenes really quickly, you want the refresh rate to be really high on your monitor to be able to adjust to those changing scenes quickly. If you're simply reading email and things like that, response time is not as big of an issue for you. Brightness is another issue. If you're in a bright room, if you have lots of windows, and you tend to use that during the day, that display during the day, brightness may be an issue. You want to be able to have a very bright monitor. Whereas if you're in a dark room, it doesn't take as much capability from the monitor to be able to produce a usable picture. Dot pitch is kind of related to resolution in that it describes the relationship between pixels on the display. If you want more detail, if you want more higher quality images, you want a smaller dot pitch. You want those pixels to be more closely related to each other. And then lastly, the contrast ratio. In other words, how much black can your monitor produce relative to how much white can your monitor produce. The more contrast you're able to produce, the better your picture is going to be. Today's monitors use a digital signal to produce a picture, so we're moving away from things like VGA inputs and outputs, I should say, to things like DVI ports and HDMI ports and display ports. My personal favorite, talked about in class, is HDMI. I like it because it includes both audio and video. It's a high quality image. We see that in use with our television displays in a lot of cases. A lot of cable boxes, for example, use HDMI ports. A lot of DVD players have HDMI ports. So I really like HDMI ports myself. As I said, gives you the opportunity to have a digital signal, produces a really good picture, and has audio built into it. Other types of displays, a lot of people will use their televisions for a display for their computer. This is possible because we have high definition television, HD TV. Almost everybody's going to have an HD TV anymore. And basically what this represents is a higher resolution television monitor. So whereas an HD TV may not be a real high quality display per se. The resolution may not be really high. It's sufficiently high to be able to produce a pretty good signal. Also, a lot of the newer HD TVs have other features built into them, which make them a smart TV. So a lot of them have the capability to be able to have Netflix built into it, or Hulu built into it, HBO Go, for example. And so this allows you to be able to utilize those services directly through the TV. The TV connects to your internet connection and facilitates those connections or those services. And it's really a nice way to not have to necessarily have your computer hooked up to your television, yet still be able to take advantage of a lot of computer-based services. The other really popular form of output are printers. And printers are, you know what printers are. They produce text and graphics and print them out on some sort of physical medium, some sort of paper usually. But before you go out and buy a printer, not all printers are created equal. Just like displays aren't created equal, neither are printers. And you need to ask yourself a few questions. What is your budget? How much money do you have? In some cases, you can get a printer really, really very cheap. But that doesn't necessarily mean that that's a good buy. For example, in a lot of cases, you can get a cheap printer, but the print cartridges cost you quite a bit. So that's something you want to be aware of. It's not just the printer that you're buying, it's how much does paper cost, how much do your print cartridges cost, things like that. How fast do your printer print? The faster your needs are for printouts, the more money it's going to cost you. Do you need color? There's lots and lots of different things that you need to ask. So be sure and look through those groups of questions before you make that decision. In general, there's a couple of different classes of printers. There are non-impact printers and there are impact printers. Non-impact printers don't physically touch the sheet of paper with the printing mechanism itself. It touches the paper to pull it through the mechanism, but the part that actually puts the image on the paper doesn't physically touch the paper. Different types of non-impact printers include inkjet printers, photo printers, laser printers, all-in-one printers. So there's a lot of different types of non-impact printers, and these tend to be the dominant type of printers that we have in use today. Inkjet printers are probably the most common. They tend to be very affordable. They produce good quality print. Speed of the printouts is very reasonable, and they can produce both black and white and color. So they tend to be very popular. Something to keep in mind when we talk about inkjet printers: one part of the tie-in to the quality of the printout has to do with the fact that every time your ink cartridge runs out and you replace that ink cartridge, you're essentially replacing it with a new head. Not only are you replacing it with the ink, the cartridge has a print head built into it. So as a result, you end up with high quality. You're replacing that print head every time you replace your cartridge. So if you're refilling your print cartridges over time, that print head quality will decline in quality. So it's something to be aware of about refilling your ink cartridges. Because of the way it works, inkjet printers don't tend to be quite as fast as some of your other alternatives, but the quality is usually quite good, and the prices are pretty good. Photo printers, you can print photos on inkjet printers, but if you really have the need for really high quality printers or high quality photos, you probably want to use a specialized photo printer. Produces much higher quality images, uses specialized photo paper, and in some cases these printers don't even necessarily have to have a computer hooked up to them. Some cameras have what they need to be able to produce or print pictures directly from the camera or send the pictures from the camera to the printer and print directly. Others will have memory card readers built into them that allow you to remove a memory card from a camera, insert it into the printer and print directly that way, again without the need of a computer. So here's kind of a good picture of a photo printer. Laser printers are a good alternative when you need to be able to have a high volume of printouts very quickly. They come in a couple of different kinds in terms of being black and white or color. Color laser printers are still pretty pricey at this point. In the early days, black and white laser printers were pretty pricey. They tended to be more heavy-duty machines. They were really positioned or targeted more towards businesses, large organizations and small and medium-sized businesses. They weren't really designed for consumer use or individual use. But those prices of especially black and white laser printers have come down significantly. You see them more in the homes. Having said this, the price is still relatively high compared to a lot of inkjet printers, and the price of the toner cartridges can be fairly high as well, especially for color laser printers. But the speed of laser printers is also very attractive to certain customers. So again, if you're in an organizational setting where you have high volume printouts that are needed, and speed is an issue, laser printers can be a good alternative. All-in-one printers are probably something that a lot of you are also familiar with. These are devices that combine multiple functions, allows you to make copies, send faxes, print things out, etc. So these are called all-in-one printers or multifunction printers. The rest of the printing sections starts to talk about some specialized types of printers. Thermal printers are ones that print out on a special kind of paper, thermal paper. And you'll see this in some cases in businesses for credit card receipts that get printed out. Some ATMs use thermal paper. You'll see this at some gas pumps, for example. I'm not a huge fan of them, especially if you're in this area of the country, you're in a hot environment. If you leave a thermal receipt in a hot car, you'll see it start to kind of turn brown and fade out, and you won't be able to read the contents of the receipt. And that's because it's a thermal printer. That printer paper is reacting to that heat. But it's just another way, another form of printing. You've also got mobile printers. These work well if you're on the go, if you've got low print volume needs. But if you're in a pinch, you can certainly make do with a mobile printer or a portable printer. In some cases, they'll have batteries that run them. In other cases, they'll plug up via USB, or they'll have their own wall connection. But it allows you to print on the go if you need to. You've got other specialized printers, including label printers that are very specialized, designed to print out on a certain type of label. Looks like in the example image here that they're printing out some sort of a barcode. So you can imagine how these might be used in an inventory environment where you need to print out labels for different items of an inventory. The example I used in class is a lot of schools will use label printers that when you go in to check in as a guest, you produce your ID, they scan it and print it out onto a label that you then wear for the duration while you're there at the school. So label printers are really very specialized printers designed to print out on a specific kind of paper, and can certainly be used in a variety of different types of environments. Still, other types of printers include plotters and large format printers. Plotters are used a lot by architects and engineers to be able to print out very fine, large-scale drawings. They'll usually have a variety of different colored pens that allow different lines to be drawn over a drawing. We've also got large format printers which operate a lot like an inkjet printer does. Allows you to print out these very large, high-quality images like you might see in posters and things like that. Both of these types of devices extremely cool and extremely expensive. So I think everybody would love to have a printer like this that they can print out these big posters, but they're not cheap. So whereas all of those represented different types of non-impact printers, impact printers physically strike the ribbon which comes into contact with the paper. So again, this is kind of a holdover from the days of typewriters. When typewriters, we would hit a key, the mechanical pen would come up, strike the ribbon, push the ribbon into the paper, and leave the mark for that particular letter that we hit. With an impact printer, it works in a very similar fashion, except that rather than having individual letters represented, or in some cases they actually would, some of the old IBM ball printers would physically have letters on them that the ball would spin around, and depending on the letter you hit, it would spin around to that letter. That letter then would hit the ribbon that would then imprint that onto the paper. This particular type of impact printer that they're demonstrating here is what's referred to as a dot matrix printer. And they're trying to illustrate how it operates down here at the bottom. So let's say they're trying to create the letter R, and this part right here represents the print head. The print head will have a series of pins in the print head. The more pins, the more detail, the finer the images that it can produce. In other words, a dot matrix printer can produce more than just letters. It can actually produce images, so the quality is not all that good. So a dot matrix printer is going to have these different pins to create dots on the page. So the very first pass, it's going to put out all of the pins to be able to create that first line of the R. But as we slide to the right just a little bit, now it retracts all the pins with the exception of this one here and this one here. For the next pass, it does the exact same thing. For the next two dots, these are retracted and these two are not. Same thing for the next one. Finally, on the very last pass, it retracts this pin here, the top pin, and this pin here, and extends all the other pins. And that's what completes out our letter R. Again, each time it's doing this, these pins are striking the ribbon, which then physically touches the paper to be able to leave that image. You don't see a lot of impact printers in use anymore. However, there are still reasons to use an impact printer over a non-impact printer. If you want duplicate copies with a non-impact printer, you have to print out multiple pages. You print out the same page more than once to be able to have duplicate copies. With an impact printer, you have the option of actually having what's called carbon paper. Some use carbonless paper, which uses a different chemical, but it basically allows you to have layered pieces of paper that once it prints out one time, you rip the paper off the printer, tear apart the pieces that hold it together, and then you can peel off the different pieces of paper behind it that have that same text that was printed on those pieces that were behind it. And that's because the carbon has gone through, it has pushed that image through not just the ink on the top copy, but then the carbon has come into contact with the pieces of paper behind that to leave that same image on those other copies. So you only have to print it one time and you still end up with multiple copies. So there are reasons to still have impact printers, but they're used less and less today. There are other types of output. So we talked about monitors and we talked about printers, but there's lots of other types of output as well. So speakers are ones that we tend to overlook, and that's one form of output. If we're in a crowded room or we have trouble hearing, we can use headphones, we can use earbuds, and that's another way to get some of that audio output out of our systems. We can also use data projectors. It's another alternative that we might have to a traditional display. Projectors sit out in front of where we're wanting to project an image. We do have certain struggles or certain issues as it relates to data projectors. If we're in very bright rooms, for example, the picture can tend to be washed out, but they do give us the ability to create very large screens. So if we have a large audience, we need to be able to have a very large image. Data projectors can help us to do that. Related to data projectors are interactive whiteboards, perhaps not quite as large as some of the data projectors, but in a lot of cases these give you additional functionalities and the opportunities to directly interact with what's going on the screen. So in a lot of ways it's very similar to a touch screen device that you might have. You can actually interact with the whiteboard directly on the screen itself. Now, at first glance, you might look at these three devices and think, well, these are input devices. For example, on the left there, we give the car gas, we hit the brakes, we steer. Those are producing input into the system, but these can actually be used to return output to us as well. For example, on the steering wheel, if we hit a curb and the steering wheel shakes, that's giving us feedback from the system. It's giving us output. So we're receiving output from the system in the form of that steering wheel jerking back and forth, representing us hitting a curb. Still other types of input and output for those that might have disabilities. There's a lot of different very specialized pieces of equipment that allow those with disabilities to still continue to be able to use technology in a variety of different ways. We may have a specialized camera and receiver that allows us to track where we're looking at on the screen, reads where we're looking at, reads what we're trying to do. We can indicate clicks in certain ways, things like that, to represent mouse clicks for people that might not be able to manipulate a mouse. On the output side of things, we have specialized printers, for example, that are able to print instead of an image on the screen or an image on the piece of paper, prints out in Braille and allows a person to be able to read that piece of paper. So there's a lot of different types of assistive technology for both input and output that allow those with disabilities to be able to continue to benefit from technology. So this chapter really kind of sums up input and output devices. Here at the end, they kind of split into these two boxes and give you the impression that half the chapter was on input and output and the other half was over assistive technology. But the vast majority of it was talking about different types of input devices and different types of output devices. And then it finishes up talking about some of those assistive technology options. So I would encourage you to go and look at some of these different things that you're perhaps less familiar with respect to input and output devices and assistive technology options. The common ones, the keyboard, the mouse, the display, the printer, those most people are going to be familiar with. But those other ones, perhaps a little bit less so. So I would encourage you to go through the text, be sure and read that information, take a look at it, and if you have any questions, shoot me a message. That is it for Chapter 7. That's all I've got for you. So until next time, take care.